Hello, good afternoon all. So today I am here again with some interview preparation question. So my first question is, how KNN is different from K-mean clustering? How KNN is different from K-mean clustering? How KNN is different from K-mean clustering? KNN is nothing but what? It is K nearest neighbor. And it is comes under in supervised classification. It comes under supervised classification. And what is K-mean? K-mean comes under unsupervised clustering algorithm. In KNN, we need label data. Okay. In K-mean, we need unlabeled data or unlabeled points and threshold. My next question is, explain how a ROC curve works. how ROC curve works. What is ROC curve? How it is work? ROC curve is nothing but what? It is a contrast between true positive rate and false positive rate. Okay. The ROC it is a graphical representation. Okay, it is a graphical representation of contrast between true positive and false positive rates. Okay, and variance threshold. It is also used as proxy. Okay. What for proxy? Proxy for trade-off between sensitivity of the model sensitivity of the model versus fallout, okay, versus the fallout, okay. What is ROC? ROC curve is graphical representation of contrast between true positive and false positive and true positive. Okay, it is also called as a proxy. Proxy for what? Trade-off between the sensitivity of model versus how it is fall out. My next question is define precision and recall. What is precision and recall? What is precision and recall? Good afternoon, Ajit. Please, guys, reply or at least message what is you understand by precision and recall. What is meant by precision and recall? So precision is first we'll get to recall is also known as true positive rate. Okay, how many true positive you having in your data? How predictions you have true predict positively true? That is what we can say recall. The amount of positives your model claim. Compared to the total actual number, total actual number of positive throughout in the data. Okay, so recall is only about only true positive rate. How we can predict or how our model is predicted compared to the all positive rates in a throughout our data. So what is the precision then we can call? What is precision then? Okay. It is known as positive prediction values. And how it is take a calculations like how it is measure of the measure amount of accurate positive amount of accurate positives your model claim compared to the number of positives in actually claim. Compare to the positives the model claims. Okay. So we'll go for the formula. Okay. Formula for recall is true positive divided by true positive plus false positive. Okay, so recall formula is true positive divided by true positive plus, sorry, it should be false negative. What is precision? What is precision formula? It is true positive divided by true positive plus false positive. Okay, so this is the formula how we can calculate the precision and recall. Okay, in recall, how we can calculate? Recall is calculated all the true positive, whatever the calculations or whatever the numbers we got from the all the data and how our model is calculate all true positive divided by the true positive plus false negative. Okay, whatever the false negative precision, whatever the false negative values he has predict. Okay, now what is the precision? It takes all true positive rates divided by true positive plus false positive. How we can uh, predict the positive value in wrong way. Okay, that is nothing but what? False positive. Next question is explain L1 and L2 regularizations. What is L2 and L1 and L2 regularization technique? What is L1 and L2? L1 is lasso and L2 is rich. Okay. Yeah, recall is also called as a sensitivity. Yes, yes, Supravat. Yeah, true positive first. Yeah, yeah, true. Very good. What is L1 and L2 regularization technique? What is L1 and L2 regularization technique? So L1 is corresponds to setting a Laplacian. Okay. And L2 corresponds to Gaussian. L2 is tend to spread error among all the term, okay, all the term, while L1 is it is more like binary, okay, with more or with many variables either being assigned to a 0 or 1 while waiting. Variables either being assigned assigned 0, 1 or 0 in waiting. Okay, that's how we can say L1 and L2 is. Now, next question is how is a decision, how is decision tree proved? Yes, Vaiva, both use in case of overfitting. Yeah, Lasso takes absolute value of loss function. What is pruning in decision tree? For what purpose we are using pruning? Okay. So pruning can be bottom up, or top down. Okay, it can be a bottom up or top down technique. Okay, for what purpose it is used? It approach each approach such as reduce error. Okay. Tuning, and also it can be cost complexity. Cost complexity tuning. We can say it is the simplest way. Okay. It is simplest version okay, it is simplest version to replace each node next question is which is more important to you, model accuracy or model performance? Which is more important to you, model accuracy or model performance? So It can be your choice, like, what you want for model, it to be more accurate, or performance should be. What is important to you? If model accuracy is good, then performance. Yes, Vaibhav, but what if your model getting new data point, okay, then it is not performing, or it not be, taking, giving accurate result. Accuracy, all are saying accuracy. Okay. So there can be a model, which is with the higher accuracy that can perform worst in predictive power. Okay, how will that will work in that sense? See, model accuracy is a subset, or it's just a set. We can say the about the model. It is just a subset of model performance. For example, if you wanted to detect fraud in a massive data set with a sample of millions, okay, uh, a more accurate model would most likely to predict no fraud. Okay, if you having a more accurate model, which is may having a low performance, so what it will do? Yeah, it will predict no fraud at all if you only, okay, vast minority of cases where fraud happens. And however, this will be useless for predictive model. A model designed to find fraud that asserts that there is no fraud at all. So for what purpose we are using that model? No? Yeah. So yeah, performance. My model performance. Yeah, it should be good. Yeah, model accuracy is just a subset of that. So it can be a question in an interview, how you wanted to, oh. So next question is, what's what is the F1's what is the F1 score? How old you use it? What is the F1 score? How old you used it? Yes, model accuracy is a subset of model performance. We can't say it is inversely proportion. It depend on the data. What kind of data you provide for the train your model. Okay, it depend on that also. It is not always depend on the accuracy and the performance. So what is the F1 score and how would you use it? What is F1 score? F1 score is measure of a model's performance. Model's performance. Okay. So it is weighted average of the precision and of the precision and recall of the model. Okay. How it can be tell that the model is good or not? We can say if trending to 0, if we are saying if it is 1, then it can be a being good model. And those who are trending to 0, those who trending to 0 being the worst, Okay. Then next question is, how will you handle an imbalance data set? How would you handle imbalanced data set? How would you handle imbalanced data set? So what will the first step we can do? We can collect more data to even the imbalance in the data set. What is the second thing we can do about imbalanced data set is we can resample it. Okay, we can resample the data set to correct for imbalances. To correct for the what is the third thing we can do about imbalanced data set? We can try with the different algorithm all together okay, on our data set. So these are the things we can try with the imbalanced data set. So next question is, name some of assemble techniques might be useful. Name some of the assemble technique might be useful. Yeah, bagging, boosting. Yeah. Yeah. First of all, we'll see what is assemble technique means. Assemble uses a combinations of learning algorithms. Okay, combinations of learning algorithms to optimize better predictive performance. Predictive performance. Okay, in this case, what will be the first case it will happen? Okay, they typically what they do, they typically reduce overfitting. Okay, because we are combining reduce overfitting. That typically reduce overfitting in the model and make model more robust. Okay, so it will not change, or it will not, change in value if in the small change in the data, in the training data, it will not change its accuracy or something else like that. Okay, and some of example is bagging, we can say boosting is there. So these are the some techniques we can, and there are numbers of algorithm we can use in assemble technique. Bootstrapping. Yes. So next question is, how do you ensure, how do you ensure model are not overfitting with model? Okay, sorry. How we can avoid overfitting? Okay. Or tell me the techniques how we can avoid overfitting. How we can avoid overfitting? Yes, guys. How we can avoid overfitting? Yeah, no answer. Please try to be active in chat window. Yeah, regularization is trimming and the future sampling. Yes. Supravat. There are only, I think, 3 or 4 people answering. Other, what happened? Okay. 3 main and the simple one I would like to tell you, that is, keep the model simple. Keep the model simpler. Okay, how we can do that? We can we can reduce variance by taking into account, we can reduce variance, okay, by taking into account where we can make fewer variables and parameters. Okay. And the second technique, we can use cross validation. Okay, we can use cross validation. Okay, such as k-fold. For example, we can use k-fold cross validation. Okay, what is the third one? We can use regularization technique. We can use regularization. Okay, such as lasso, as we have seen, such as lasso. Okay, what it can do, it can penalize certain parameters. Okay, which cause overfitting, or which cause overfitting in our model. So by using lasso, we can penalize that certain parameters. So we'll stop today, and I would like to ask you guys, please, if you have any topic or what on topic you want today, tomorrow's session will be, for interview question we should take. So please be active in chat and tell me which topic you will want. Yeah, also clustering. Yeah, we can use clustering. Yeah, guys. What I am asking you to is, if you want a particular topic, so if you have any topic, so we'll go with that too. So if you have any topic, then suggest in chat box. We'll go with that topic tomorrow. Yeah, reducing variance. Yeah, Mahesh, you are answering something or what, like? Okay, guys, if you have a topic, then please reply in chat box if you want any topic. For today, we'll stop here. Thank you, guys, and bye. Okay, business movement decision. Okay, all topics is not Supravat. All topics is not, in one day we can do all topics. So I just wanted to, if you have anything like, otherwise I'm going like supervise, then agglomerative. Yesterday we have taken. So that's what I want. Okay, thank you guys. We'll stop for today and we'll meet tomorrow. Bye. Yeah, Mahesh, you want me to explain how lasso works? Okay. Okay, Mahesh, I'll explain you tomorrow how lasso works in brief tomorrow because today it might end the other session in between. Okay, so meet me tomorrow, same interview preparation session. I'll start with the how does lasso work. Okay, okay, definitely. I would like to help you guys.